SQL has three sub-languages: Data Definition Language, DDL, Data Manipulation Language, DML, Data Control Language. DCL, DDL is used to define the database schema, define the structure of tables, and modify the structure of the tables. DML is used to add data to, retrieve data from, and modify data in tables based on the structure of the database defined by the DDL statements. DDL statements are executed once for every database to define the structure. After the structure is defined, operations are performed through DML statements. The into clause. You use the into clause to retrieve data from a database through a select statement into the variables in the PLSQL block. The into clause is mandatory and occurs between the select and from clauses. You must specify one variable for each item retrieved from the database. The order and type of the variables must correspond with the items selected. You generally use the into clause to populate either PLSQL variables or host variables. In the code in slide, the v_emp_hire date and v_emp_ salary variables are declared in the declare section of the PLSQL block. In the executable section, the values of the hire_date and salary columns for the employee with employee_id100 are retrieved from the employees table and stored in the v_emp_hire date and v_emp_ salary variables, respectively. Observe how the into clause, along with the select statement, retrieves the database column values and stores them in the PLSQL variables. In the example in the slide, the v_sum_sal and v_depno variables are declared in the declarative section of the PLSQL block. In the executable section, the total salary for the employees in the department with department_id60 is computed by using the SQL aggregate function sum. The calculated total salary is assigned to the v_sum_sal variable. In potentially ambiguous SQL statements, the names of database columns take precedence over the names of local variables. The example shown in the slide is defined as follows. Retrieve the hire date and today's date from the employees table for employee_id176. This example raises an unhandled runtime exception because, in the where clause, the PLSQL variable names are the same as the database column names in the employees table. Avoid ambiguity in the where clause by adhering to a naming convention that distinguishes database column names from PLSQL variable names. Database columns and identifiers should have distinct names. Syntax errors can arise when you have identifier names that are the same as database column names because PLSQL checks the database first for a column in the table. You manipulate data in a database by using DML commands. You can issue DML commands such as insert, update, delete, and merge without restriction in PLSQL. Row locks and table locks are released by including the commit or rollback statements in the PLSQL code. The insert statement adds new rows to the table. The update statement modifies existing rows in the table. The delete statement removes rows from the table. The merge statement selects rows from one table to update or insert into another table. The decision whether to update or insert into the target table is based on a condition in the on clause. In the example in the slide, an insert statement is used within a PLSQL block to insert a record into the employees table. While using the insert command in a PLSQL block, you can use SQL functions such as user and current_date. Generate primary key values by using existing database sequences. Derive values in the PLSQL block. Let us first see the current state of the table before we run the update in the PLSQL block. For simplicity, we will see only 5 rows of the result set. You can see the actual result when you execute the code in your workstation. The select statement retrieves the first _name and salary of employees whose job_it is. st_clerk. Execute the PLSQL block with the update statement. If the block executes without errors, you see the response PLSQL procedure successfully completed on the script output tab. Execute the same select statement again to see the update in the employees table. You see the new values in the query result as a result of the update operation. The delete statement removes unwanted rows from a table. If the where clause is not used, all the rows in a table can be removed if there are no integrity constraints. The code shown in the slide deletes the row from employees table whose employee_id equals 176. The merge statement inserts or updates rows in one table by using data from another table. Each row is inserted or updated in the target table depending on an equijoin condition. The example in the slide matches the emp_no column in the copy_emp table to the employee_id column in the employees table. If a match is found, the row is updated to match the row in the employees table. If the row is not found, it is inserted into the copy_emp table. The Oracle server allocates a private memory area called the context area for processing SQL statements. The SQL statement is parsed and processed in this area. The information that is required for processing and the information that is retrieved after processing are all stored in this area. You have no control over this area because it is internally managed by the Oracle server. SQL cursor attributes enable you to evaluate what happened when an implicit cursor was last used. You can use these attributes in place SQL statements but not in SQL statements. You can test the SQL %row count, SQL %found, and SQL %not found attributes in the executable section of a block to gather information after the execution of the appropriate DML command. Place SQL does not return an error if a DML statement does not affect rows in the underlying table. However, if a select statement does not retrieve any rows, place SQL returns an exception.